This lecture is on working with Mass-Mass and Mole-Mole Stoichiometry. Stoichiometry involves studying the quantities of chemicals present in a chemical reaction. A key when performing these types of problems is by studying the mole ratio between any two substances in a balanced chemical equation. Let's look at an example. Suppose you have the following reaction: 2A forms B. What relationships can be inferred from this balanced chemical equation? The equality is 2 moles of A equals 1 mole of B. The two converting factors are 1 mole of B over 2 moles of A and 2 moles of A over 1 mole of B. Exercise 1 involves mole stoichiometry and is what amount of O2 will be obtained by heating 3.50 mole of KCl3. The balanced chemical equation is 2 KCl3 forming 2 KCl and 3 O2. The mole ratio converting factor is 3 moles of O2 over 2 moles of KCl3. Using the solution map, moles of KCl3 to moles of O2. Therefore, 3.50 moles of KCl3 after multiplying the converting factor of 3 moles of O2 over 2 moles of KCl3 produces 5.25 moles of O2. Exercise 2 involves gram-gram stoichiometry and is what mass of H2O is produced from 7.25 G of C3H8 in excess O2. The balanced chemical equation is C3H8 plus 5O2 forms 3CO2 plus 4H2O, all gaseous substances. Given that the mass of C3H8 is 7.25 G and the balanced chemical equation is provided, one needs the converting factor between moles of C3H8, 2 moles of water or H2O, which is 4 moles of H2O over 1 mole of C3H8. Additionally, one needs to know the mole mass of C3H8 and H2O, which are 44.09 G per mole and 18.02 G per mole, respectively. Using the solution map, we start with G of C3H8 and convert to moles of C3H8, then convert to moles of H2O and ending with G of H2O. After plugging in the values into the setup, 7.25 G of C3H8 produces 11.9 G of H2O or water. A limiting reactant or limiting reagent is defined as the reactant that is completely consumed in a chemical reaction. An excess reactant or excess reagent is defined as the reactant that remains at the completion of a reaction. The limiting reactant or limiting reagent will always determine the theoretical yield of a reaction based on the initial quantities of all reactants. One can determine the effectiveness of a reactant by calculating the percent yield. The percent yield equation is actual yield divided by theoretical yield times 100%. Sample problem example 1 is, suppose you have the following balanced chemical equation. 2 pieces of bread plus 1 slice of cheese forms 1 cheese sandwich. If you started with 6 pieces of bread and 2 slices of cheese, A, what is the limiting reagent? B, how many cheese sandwiches can be produced? And C, what is the excess reagent and what amount will remain after the completion of the reaction? Sample problem example 2 is, suppose you have the following balanced chemical equation. 2H2G in parentheses plus O2G in parentheses forms 2H2L in parentheses. If you started with 6 moles of H2 and mixed with 4 moles of O2, A, what is the limiting reagent? B, how many moles of H2O can be produced? And C, what is the excess reagent and how many moles will remain after the completion of the reaction? Sample problem example 3 is, suppose you have the following balanced chemical equation. N2G in parentheses plus 3H2G in parentheses forms 2NH3G in parentheses. If you start with 4 moles of N2 and mix with 3 moles of H2, A, what is the limiting reagent? B, how many moles of NH3 can be reduced? And C, what is the excess reagent and how many moles will remain after the completion of the reaction? Please try each of these practice exercises first, and if you want to check your answers, visit the following links for solutions listed below. When working with limiting reagent problems, you may encounter situations involving moles of A to moles of B. However, for most others, it will be grams of A to grams of B. Regardless, it is important to have a balanced chemical equation and a periodic table handy in working these types of problems. The solution map is G of A to mole of A to mole of B to G of B. Let's look at some examples. Exercise 3 involves a limiting reactant involving grams of A to grams of B. 11.1 G of H2 and 33.3 G of Cl2 are mixed in a reaction vessel where formation of HCl gas is noticed. Calculate the mass of HCl formed. The reaction is H2 gas in parentheses plus Cl2 gas in parentheses forms 2 HCl gas in parentheses. The problem provides the masses of H2 and Cl2, which are 11.1 G and 33.3 G respectively. The items needed are the following. The molar masses of H2, Cl2, and HCl, which are 2.016 G per mole H2, 70.90 G per mole of Cl2, and 36.46 G per mole of HCl. Additionally, we need the mole ratio between H2 and HCl, which is 1 mole of H2 over 2 mole HCl, and also the mole ratio between Cl2 and 2HCl, which is 1 mole of Cl2 to 2 moles of HCl. The solution map to go from mass of H2 to mass of HCl is by starting with G of H2, and after dividing the molar mass of H2, get moles of H2, which then one multiplies by the mole ratio of HCl over H2. And lastly, multiply the molar mass of HCl to get G of HCl. The solution map to go from mass of Cl2 to mass of HCl is by starting with G of Cl2, and after dividing the molar mass of Cl2, get moles of Cl2, which then one multiplies by the mole ratio of HCl over Cl2, and lastly, multiply the molar mass of HCl to get G of HCl. For the mass of HCl from the mass of H2, after plugging in all the values, 401 G of HCl is produced from 11.1 G of H2. For the mass of HCl from the mass of Cl2, after plugging in all the values, 34.2 G of HCl is produced from 33.3 G of Cl2. It turns out that the limiting reagent is Cl2 because it produces the least amount of product, so the theoretical yield is 34.2 G of HCl produced. Exercise 4 involves both theoretical yield and percent yield, and it is 15.4 G of methanol reacts completely according to the following reaction. CH3OH, G in parentheses, forms H2O, G in parentheses, plus H2, G in parentheses. Methanol is CH3OH, and formaldehyde is CH2O. If 12.35 G of formaldehyde is produced, what is the percent yield for this reaction? The given information is one has 15.4 G of methanol, and the actual yield is 12.35 G of formaldehyde. What is needed is the molar mass of CH3OH, which is 32.04 G per mole of CH3OH, molar mass of CH2O, which is 30.03 G per mole of CH2O, the mole ratio of CH3OH to CH2O, which is 1 mole of CH3OH over 1 mole of CH2O. The percent yield equation is actual yield divided by theoretical yield times 100%. To get the theoretical yield of formaldehyde, or CH2O, it begins by taking the mass of CH3OH and dividing it by the molar mass of CH3OH to get moles of CH3OH. Then multiply the mole ratio between CH2O over CH3OH. And lastly, from the moles of CH2O obtained, multiply by its molar mass to get the theoretical yield. After plugging in the numbers, 14.4 G of CH2O is produced. Now one can obtain the percent yield by taking the actual yield of 12.35 G and dividing it by the theoretical yield of 14.4 G, and after multiplying it by 100%, get 85.8%. Exercise 5 involves the limiting reactant and excess reactant. The problem is zinc plus sulfur react to form zinc sulfide according to the following equation. Zn plus S forms ZnS. If 25.0 G of zinc and 30.0 G of sulfur are mixed, A, which chemical is the limiting reagent? B, how many grams of ZnS will be formed? And C, how many grams of the excess reagent will remain after the reaction is over? Given we have 25.0 G of Zn and 30.0 G of S, one needs the molar mass of Zn, S, and ZnS, which are 65.39, 32.07, and 97.46 G per mole respectively. One also needs the mole ratio between Zn and ZnS, which is 1 mole of Zn over 1 mole of ZnS. And for S2 ZnS, it is 1 mole of S over 1 mole ZnS. For converting mass of Zn to mass of ZnS, the solution map is as follows. Start with the mass of Zn, convert to moles of Zn by dividing it by the molar mass of Zn, then multiply by the mole ratio between ZnS and Zn, and lastly, multiply the molar mass of ZnS to get G of ZnS. For converting mass of S to mass of ZnS, the solution map is as follows. Start with the mass of S, convert to moles of S by dividing by the molar mass of S, then multiply by the mole ratio between ZnS and S, and lastly, multiply the molar mass of ZnS to get G of ZnS. It turns out that 25.0 G of Zn, after plugging in all the values, produces 37.3 G of ZnS. It turns out that 30.0 G of S after plugging in all the values produces 91.2 G of ZNS. Since 37.3 G of ZNS is the smaller mass of the two answers, this is the theoretical yield of this reaction. And the limiting reagent is Zn. Now, for part C, in determining the mass of the excess reagent of S, one needs to begin with the mass of Zn. And that can be done by taking the mass and converting it to moles of Zn by dividing it by the molar mass of Zn. Next, convert to moles of S by using the mole ratio between Zn and S, and finally multiply by the molar mass of S to get mass of S. It turns out that 25.0 G of Zn requires only 12.3 G of S. To determine the mass of S remaining, one takes the initial mass of S and subtract from the reactant mass of S. So 30.0 G minus 12.3 G equals 17.7 G of S. And this is the unreacted mass of S after completion of this reaction. Review exercise involving limiting reagent and theoretical yield includes the following problems. Solve each of the following problems. A, how many grams of Al2S3 are formed when 5 G of Al is heated with 10 G of S? The reaction is 2 Al S in parentheses plus 3S S in parentheses forms Al2S3 S in parentheses. B, aluminum chloride can be made by the reaction of aluminum with chlorine according to the following equation. 2Al plus 3Cl2 forms 2AlCl3. The state of matter for AlCl2 and AlCl3 are S in parentheses, G in parentheses, and S in parentheses respectively. What is the limiting reactant if 20.0 G of Al and 30.0 G of Cl2 react with each other? And what is the theoretical yield of AlCl3 that can be produced in grams? Review exercise involving theoretical yield and percent yield includes these problems. Solve each of the following problems. A, 9.87 G of ammonia react completely according to the following reaction. 2NH3 G in parentheses plus CO2 G in parentheses forms NH2 in parentheses 2 CO S in parentheses plus H2O L in parentheses. 13.74 G of urea are produced. What is the percent yield for this reaction? B, 85.4 G of chlorine reacts completely according to the following reaction. P4S in parentheses plus 6Cl2 G in parentheses forms 4PCl3 L in parentheses. If 104 G of phosphorus trichloride is produced, what is the percent yield for this reaction? Review exercise involving limiting reagent, theoretical yield, and percent yield includes this problem. Solve the following problem. When iron 2 hydroxide is mixed with phosphoric acid, iron 2 phosphate precipitates as shown in the balanced chemical reaction. 3Fe OH in parentheses 2 S in parentheses plus 2H3PO4 AQ in parentheses forms Fe3PO4 parentheses 2 S in parentheses plus 6H2O L in parentheses. A, if 3.20 G of Fe OH in parentheses 2 is treated with 2.50 G of H3PO4, what is the limiting reagent and what is the excess reactant? B, how many grams of Fe3PO4 parentheses 2 precipitate can be formed? And C, if 3.99 G of Fe3 parentheses PO4 parentheses 2 is actually obtained, what is the precipitate? Review exercise involving limiting reagent and excess reagent includes this problem. Solve the following problem. Silver nitrate reacts with ferric chloride to give silver chloride and ferric nitrate according to the balanced chemical reaction. 3AgNO3 AQ in parentheses plus FeCl3 AQ in parentheses forms 3AgCl S in parentheses plus FeNO3 parentheses 3 AQ in parentheses. A, what is the limiting reactant and the theoretical yield of the precipitate in grams? And B, how many grams of the excess reactant will remain after the reaction? For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.